Okay, well, good evening, everyone, and good morning, Switzerland. I think we'll get started. We still have a few people that are logging on. I think everyone's just finishing up a busy day. So I'd like to welcome everyone to this webinar this evening. We're very, very excited to be able to present a preview of some new solutions and platforms from Dental Axess. So I would like to introduce Per Clayson, and I know for most of you, you do know Per. So Per is situated in Zurich, and he's going to provide some insights and experience on the laser aligner cutter, as well as present how this fits into the clear aligner workflow. So, Per, I'm going to hand it over to you. I'm going to leave it in your hands, and I know we will have some good discussion at the end of the presentation. So, if you do want to add a question or write something down, you can always write your questions in the Q&A session. But definitely at the end of the presentation, we'll for sure open up for questions and some good discussion. So, thank you, Per.
Great. Thank you so much, Belinda, and good morning from Zurich. I guess good afternoon and good evening to Australia, depending on where you are. Thank you so much for the invitation. I very much look forward to update you a little bit on what we have been doing in the clear aligner space. As Belinda mentioned, we have some great new solutions, but I wanted to actually really start with really recapping a little bit how we look at our clear aligner workflow. What is very important to know is that our philosophy is that you don't need to either work in a specific way or use particular products to complete the clear aligner workflow. You can step in basically at any point and also exit at any point. It's important for us to give everybody that flexibility. So of course we have our own fully validated workflow from start to finish with certain equipment, but it doesn't mean that you need to do it necessarily that way. We can also work with integrating existing equipment that you may have in your environment. But I wanted to start a little bit with this picture to look a little bit at the workflow. I will go in more in detail later on the different steps, but this is more to really give an overview. So these steps already. Of course, we have the scanning side, we have treatment planning, we have 3D printing, we have thermoforming, and we also have the cutting of the aligner. Basically in here, we have different solutions to complete these steps. But again, they can also be other options potentially. What is unique now in our solution is that we basically have one platform that manages all the different steps. So we see, of course, that in the market today, there is a lot of different islands. You have scanners, you have treatment planning softwares, you have printers, but the whole workflow is not really hanging together. So we spent a lot of time on basically building one cloud-based platform to hold these different steps together, making sure that the data is all in one place and can retrieve by the different components, as well as really having a very good track of cases, as well as being able to share them with third parties like referrals or even end customers like patients. And that's what we have built the XFlow platform for. So I will go into all these different steps a little bit later on in my presentation. What I also want to mention here is that you always have the option to do steps in-house, or we're also given the option to outsource these different steps. That could be, for example, that you have a capacity increase and cannot handle certain steps in-house, or you have a staff member leaving, or some equipment failure happens, because they do happen. That's why we have been very important for us also to build in kind of a outsourcing step for each of those steps. So you could outsource, for example, the treatment planning, you could outsource just the printing, or you could actually outsource the full manufacture of the aligner if need be, to us and our manufacturing partners. So I will go into these different steps a little bit more in detail. First of all, like I mentioned before, XFlow. XFlow is really our data management hub. It started really off as a platform to manage data for clinicians safely and securely. So it means that you could connect directly with a validated connection, your intraoral scanner, store all the 2D and 3D data in one cloud-based platform, use it for patient consultations, as well as sharing data with your partners, whether it's referrals or labs. But we have now also extended XFlow to also handle cases, so that from a scan, for example, you can then create an order, let's say for an aligner. And in this workflow, we really support the different steps that, for example, getting a treatment plan, either in-house or sending it to a design service to be done. And then once you have the treatment plan, you can review that. You can send a link to a patient to review the case. And then also, of course, once it comes to manufacturing, this platform also allows you to handle all the print files, as well as later on also the trim lines that we need to use if we use a laser aligner cutter. So XFlow is really kind of the holder of all the data and keeping track of the cases. But we have then made interfaces to XFlow to handle the different treatment planning softwares or 3D printers so that we can retrieve the data. So if you haven't looked at XFlow, you can go to our website, dentalaxess.com/XFlow, and you can even actually sign up for a free month to just have a play with it and see how that solution looks like and works. So the first step in any clear aligner workflow is, of course, the scanning. Of course, we as Dental Axess, we have validated and integrated the scanners we offer, which is essentially FreeShape and Medit, both actually the intraoral scanners as well as the desktop scanners. So from both scanners, you can seamlessly send data into the data management platform XFlow. So you don't need to worry about dragging and dropping STL files and so on. It seamlessly enters the platform. But of course, we know that there is other scanners out there as well. So we also support third-party scanners. At the moment, you do work with STL files from these scanners, but we also have in our plan to also do more integrations directly also with third-party scanners. So it doesn't really matter if it's an intraoral scan or if it's a desktop scan. That's obviously how we get in the data. And of course, in our platform, we can also receive 2D photos, of course, as well as X-rays, so that we can basically compile all the records we need around the patient into one platform. So this is really the scanning step. Once we have the scan data, we will then go into treatment planning. And here we have different options in our concept. So some of you may already worked with Xplan. That's our fully integrated web-based platform, where you always have the option to do the full design yourself, or outsource the full design procedure, or do something in between. And with that, I mean, for example, we could just prepare the case by segmenting the teeth, and then you do the setup yourself, or you decide to do everything yourself. That's also possible. So you have various options in Xplan what you want to do yourself, and what you want to outsource. And I think what is really unique with the platform, especially now in combination with XFlow, everything is web-based. So you don't need to install any desktop-based softwares. It all sits in the cloud, and you can retrieve your cases from anywhere. Also, even when you want to do design changes, you use the Smart Studio that's also web-based. So everything hangs together in the cloud, which is really unique. The second integration we have done as well outside of XPlan is FreeShape ClearLiner Studio. Some of you might be using it today already, and that means that you can retrieve data from the XFlow case management platform, design it in ClearLiner Studio, and then upload the case into XFlow again, and that's where you can share the case with a viewer and so on. So also FreeShape ClearLiner Studio is an option. Probably for those that haven't maybe updated ClearLiner Studio, there is quite a lot of new features in it, such as automatic segmentation now of the teeth. As well as, which we'll go into a little bit later on, you would also need, of course, the trimline functionality if you use a laser cutter. So that's also designed in this step. We're setting, both for XPlan and for FreeShape ClearLiner Studio, we're basically setting the trim line for the cases in the last step in both software platforms. If you outsource the design, we can, of course, set the trim line for you according to your preferences, whether they should be scalloped or whether they should be straight or scalloped in the anterior and then straight. That is also option now to have that as a design service option. So this is a treatment planning step. This is currently the platforms we support. Then coming to the next step, we have scanned, we have now designed the case, now it comes to the printing. Many of you probably work with Asiga already. It's something that we have had very, very good experience with in general. It's great also, of course, that it's an Australian company. We get really great support from Asiga, and we also see them as very innovative. But most importantly, they also share this open philosophy that we have, that you should be able to use any material when you're printing, because in the 3D printing space, things develops extremely rapidly. And the materials that we use today, we're certainly not going to use tomorrow. That's just how it goes. So we believe that it's very important that you have an open 3D printing system where you can use materials from different providers, because this speeds up innovation. We've certainly seen it in the clinical space with Asiga, for example, being able to print bite splints directly, sleep appliances, guides, and so on. And now even some final materials such as crowns and denture bases and so on. I think without the open material option, we would never have had these materials coming to the market so rapidly. So that's something that talks very strongly for Asiga, plus also the reliability we've had of these machines. So we work basically with two different Asigas. We work with a Max UV, which is really like an entry-level printer where you want to have quite small build plates, but it's a great start. And what we see that once someone transitions from a Max UV, maybe as the entry point, into Pro 4K, they keep then using the Max UV as, for example, a printer dedicated for a certain materials, for example, bite splints, where we have the Keystone soft splint material, which is super nice to work with, and then they have a dedicated printer for that. So it's a nice platform to also grow in, many of our customers are now on the 4K. It has a large build plate. You can print around 30 to 40 minutes a tray with models flat, and so it gives really good speed, really good versatility. Generally, what we have seen, and this comes back down to numbers, really, so that generally when we have seen when a customer had two Asiga Pro 4Ks, that's when it starts becoming interesting to look for a more industrial solution, purely based on economics. So the next step for us is always to introduce customers then to Prodways for the Pro makers, LD10 and LD20. It's a numbers game, so we have a really good calculation sheet, and it turns out that if you have you know, a model production that needing 2 printers or more of a SIGA 4K, we do see that it's a good investment to look at the numbers of going to a more industrial printer rather than adding more 4Ks. But depending, of course, a little bit of the applications. If you have a lot of different materials you use, it could also be an option to have a third a SIGA Pro 4K. So important for us here is that we cover the full space from entry level to industrial. Of course, as I mentioned before, you don't need to use any of those printers to work in our workflow. It's just that with these printers, we integrate them more tightly, we validate, we test. But of course, with XPlan and XFlow, you can also, of course, output models in STL format and print them also on another type of 3D printer. So you don't have to use these printers to stay in the clear aligner workflow. Something that is new to our portfolio is also thermoforming, where we have been doing a lot of investigative work. We have tested a lot of different solutions from different suppliers. It is important for us to be able to really give a full solution, A to Z solution, as I mentioned. So we also now carrying the Shoei portfolio of thermoformers. So both the BioStar and the MiniStar, generally for clear aligners, we use mostly actually the MiniStar. There is some reasons for that. That is, you will see this later on. We don't use these little stones, which is better managed in the BioStar. But when we work with clear aligners and printed models, we don't need these stones to level the model. So the MiniStar works really well for that. We also thinking when you're serious about clear aligners, we always believe that redundancy is key. So we see many customers having 2 MiniStars, which is almost the price of one BioStar. So this is also something to consider. So we have them now in our assortment. Something also that is important when it comes to making the foils is that we have, of course, 2 different types of systems in the market. We have pressure-based thermoformers and we have vacuum-based thermoformers. From the testing that we have done, we do find consistently that we're getting better results with the pressure system, because we really see that it also covers really well the undercuts. Whereas when we have looked at some vacuum-based systems, we may end up with some gaps and not getting the same type of retention. But again, we also supporting, of course, other thermoform systems in the workflow, third parties. It's also optional. With Shoei, we have also introduced some materials from them in our portfolio. We generally have 2 types of foils that we supply. We have the Duran Plus and we have the CR Pro Plus. So I will start with Duran. Duran is kind of your classical foil, very proven foil in the market based on PETG. And we carry 3 different thicknesses of the material, a 0.5, a 0.75, as well as a 1 millimeter foil. Normally we use this for different indications. So if one uses 2 layer principle, mainly starting patients off with a little bit of a softer, easier to wear material, one can start with 0.5 and then go to 0.75 afterwards if you use that combination. And of course, also normally we recommend the Duran for retainers, where we normally use the 1 millimeter option. The plus, so they normally come in plus and not plus. What plus does is that it basically adds a protection film inside the aligner. That is very, very important when we work with 3D printers and 3D printed models, because the model that we print is generally not a medically cleared material. It wouldn't be a class 2 or class 1 material even. And that means that we need to make sure that we have no toxins moving from the printed model into the aligner, and that's why we're using a protective film in between. This film is removed after the cutting of the aligner. It's very easy. It just takes a second or two, putting a scalpel in one end and pulling it out. But we highly recommend that is used for any printed models when you're doing thermoforming. The other material also that we have now in our portfolio is the CA Pro Plus. This is a new type of material, which basically using a 3-layer technique. I will come back to the properties a little bit later, but since the properties are more consistent throughout, it's a little bit easier also and comfortable for the patient to wear. Hence, we basically recommending only to use the 0.75 millimeters, so it makes it a little bit easier also to stock. What is very important with the CA Pro is that they are individually vacuum packed, so they are sensitive to moist particularly. So you really need to take care here of shelf life and keep these in the right storage conditions. The material, many people will probably compare it with Sendura in terms of its properties. It is because we have this 3-layer material inside it. So it has a flexible core and then a hard shell on the sides. And the idea with this is that we maintain really a constant force throughout the process, rather than having initially very high and later on very low. So if we compare here, basically conventional aligners, or we can also put Duran in here, you can see that we have a very high force initially with the conventional aligner foil or Duran, whereas CA Pro is less. But the difference here is that we don't lose that force as quick when we're using CA Pro. So it is more comfortable for the patient to wear initially, but also it keeps the consistency throughout the full step, right? So it also could be situations where we can even play with a little bit faster movement when we're using CA Pro. That is what we have seen so far. So we can increase the transition speed when using CA Pro. So it is a more expensive material, but it's also worth thinking about it. Is it possible to reduce some steps using CA Pro and still giving the patient the comfort that we wish to deliver? So 2 new materials from us. They're available now, and you can get them also, of course, from our Australian office. So this is basically how we position thermoforming for entry level and advanced. So generally what we see is customers growing up to maybe 4 or even 6 thermoformers before looking at the next step. And we do have some customers which also work in the industrial space for thermoforming. The main difference here is that we use rolls instead of individual sheets, and we use basically these packaging cells that thermoforms the aligner. So it's more basically conveyor belt style. You basically load it with models on a tray, and then automatically the machine will thermoform. The difference between the two is that the bigger one can handle different temperature settings. So if you use a lot of different type of aligner sheets, it can accommodate that in different batches, whereas the smaller one has the ability to to handle one type of material at a time. So with that said, we move now into the most exciting part, at least I think that's what is also new. That is the laser aligner cutter. It's a project we have been working on now for around 2 years in the making. We had a long design phase, a lot of thinking about it. What is, I guess, most important in this space, and I think what many forget, is the most important thing about a cutter is the integration and the handling of the machine. So sure, you can buy a milling machine, you can make that an aligner cutter, it's also possible, but the most important aspect here is that everything flows. So when we put in an aligner, the machine needs to know which aligner it is, and it needs to load the right trim line, it needs to cut the right aligner, and it needs to then be in constant communication with the design software or the platform that handles the cases. That is the key thing, because otherwise you end up in a situation where you manually have to load in files, manually select jobs, and then in the end, the room for mistakes is very big. So a lot of the development process was actually not so much just about the machine, it was really to develop a really integrated workflow, which is super easy to handle for also a low-skilled operator. You should be able to have a 1-hour introduction to the machine and then should be able to work with it without any previous experience. That was our goal. I will go through the different steps, how it works, and then we will also watch a little video about it. So what is very unique with the LAC is that we basically cut the foils without the model. And there's two different reasons for it. First of all, it's a technical reason, and that is that if you can imagine, we have the foil over the model, and we cut it with the laser. There is here a risk that the laser penetrates the plastic and go into the printed model material. And it's the same issue there. If we then heat up that model material, there is a high risk that the toxins can also then transfer through to the actual aligner. So that means that if we would go down that path, we would also need to have a clinical material for the model material, which will increase resting costs for sure, and will make the solution much less versatile. So we decided for that reason that we should cut it without the model. And the second part to that is also there is some very strong patents on cutting aligners with laser on a model. So that's why you mainly in the market today don't really see any other laser aligner cutters, because if they would cut with laser on a model, they would also breach patents. So we decided that laser is by far superior for the cutting, you know, because we don't have any tool wear, we don't have any debris, we don't have any smell, we also don't have any load on the machine because we're not pressing on something like we do in a milling machine. So we also believe that the maintenance aspects are much easier. So that's why we decided to go with laser as technology. And secondly, also to just show the different steps here to cut it actually outside or without the model. Essentially what we do, we have also developed here a concept for how we separate the foil from the model. You will see it more in detail in the video, but just as an overview, we basically have a special insert that we put in the thermoformer that holds the model down. Then we thermoform on top on this special holder. The holders, they work with Shoei, they work with Ercodent. We thermoform the foil on top. And then we have a special separator. You will see it again in the video that separates then automatically the the foil from the model. Once we have done that, this in many cases is done before. You have already set the trim line in the design software, and if you use the XFlow and XPlan platform, our software communicates directly with the milling machine, so you don't even have to select which job you're putting in. We have a little barcode on the actual sheet, so that once you're putting the aligner into the machine, it will read this code, so it knows which aligner it is. But not only that, you will see on the video that the first step that happens is that the aligner goes into a little chamber. So in this chamber is a camera. So there's a few things determined there in that step. First of all, what orientation we have put the aligner sheet in. So we don't have any special jigs or anything like that. We're just putting the actual foil into the machine. So it doesn't matter what orientation you put it in. The camera will know that. And secondly, it reads, of course, the code, so it knows which aligner step and which patient we have put in the machine. And then thirdly, it also do a validation check. It also reads the shape of the thermoformed foil, and it compares that with the original STL file to ensure that we actually have put in the right model again. So we have a number of verification steps there. So there is a camera that provides all this logic essentially. But that makes this handling super easy. You don't need to worry about how to put it in. You don't need any special jigs, anything like that. Just put the foil in, the suction holds it down, and then we will start the cutting. What excites me absolutely the most with this machine is that there is no post-processing needed. It's something that I can really swear on being the most exciting part of it. When we get this aligner out of this machine, you don't need to touch it. It is super, super smooth. So it's designed that the aligner can go directly for packaging and sent to the patient. That is super exciting. The other thing also that the machine has, it does have a laser engraving feature. So the laser will also be able to engrave the step number and, for example, initials or ID number of the patient if need be. So that's also inbuilt into the unit. So having said this, I'm going to see, hopefully this video works and everybody can see it. I will show a little demonstration of these steps. So this is obviously after we have done the printing and after we've done the models. And then you will see how the actual thermoforming works and also how the actual cutting works. So hopefully everything runs the way it should. I will just press play here, and then hopefully you can see the video here. So a little bit of different steps here. The first thing that happens is that we place the model on this special holder. It has little strings that attaches the model to this special plate. The plate is then placed in the thermoformer. So we have one plate for Shoei, one plate for Arcodent. We heat the foil, we thermoform, and once we have done the thermoforming, we're putting it into the separator. And this separator comes with the laser aligner cutter. So we put it into the separator like this. Then we put a cap on top. This cap is used to create essentially a vacuum inside. And then we press down the handle. And then the foil is separated. And what is super cool with this is that we have tried it on a lot of difficult cases, and we never break the model. So the model can be reused if need be. They always stay intact. And now you can see how we're putting the sheet in the laser aligner cutter. It just clips down, and then it has a suction that holds it in place from underneath. And as I mentioned, the first step is that the aligner goes up in this chamber, and that is where we verify which aligner it is from which patient, as well as what orientation is put in. And then finally, we do a verification that we have loaded the right also model based on the shape. So we also do a shape verification with the camera against the original STL file. And also during this step, the calculation of the cutting line is done basically in real time. So now after this step is ready to cut. So you don't really see the laser, it's invisible. You may have to look very, very careful of the video, and you can see how a line is being made here. It's rather fascinating because you don't have any smell, you don't have any smoke or anything like that. So it's quite difficult to see, but you can see here you probably see a little bit how the line is shaped under the teeth here. And it's a full 5-axis machine, so we can basically attack it in any angle. And the cutting itself takes around 20 to 30 seconds, but with the reading and verification and calculation of the cutting line, we are around 1 minute per aligner in total from loading to offloading. And as you saw here, this is also very unique. You could directly just pull the model or the actual aligner out of the plastic. So there is no pins, no residues left, because actually the suction is holding the aligner down. So once it's cut, you basically with 2 hands just lift it off. It's totally separated, and it is absolutely ready to go into the mouth. So with this, that is the new laser aligner cutter. Basically, we are in the process now. We have had it in beta tests since end of last year. It's been progressing really well. We put it in our production partners lab as well. So we have done high volume with it, and we essentially starting deliveries now in end of March, early April, essentially. So that concludes what I had to say. Of course, if you want to stay up to date with all of those things, do follow us on our social media channels. We post a lot of videos, a lot of cool stuff there on what we're doing. So you can follow us on LinkedIn, you can follow us on Facebook and Instagram, and also, of course, sign up to our newsletter, because then you're always ensured to have the latest information from us. So with this, I'll conclude my part. Maybe, Belinda, I hand it back to you from here.
Great, thank you, Per. That was fantastic. Just to let everyone know, as Per mentioned, we are launching this now. We're taking pre-orders now. Also, we will have a unit available at ADX to view. Okay, well, I think we may finish up there. Of course, if anyone has any other questions, feel free to reach out to either myself or Zoe or Melissa. Happy to take any calls on this. Now, as I said, we will have a unit on display at the ADX in Sydney.
And I'll be there too.
Oh, yes, that's right. So we'll see Per there. Yeah. So you will get to see the machine. It's actually sitting in this big box behind me. So I don't take my eyes off this box. It doesn't leave my sight. So with that, I'd like to thank everyone for joining. As we mentioned, it is a preview. And of course, if any of you got any feedback at all for us. I think it's really important. That's why we wanted to get this select group of people together. Give us any feedback, any thoughts. We'd be happy to yeah, happy for your feedback, that's for sure. So thank you, Per. I think we've had a really good discussion this evening, and yeah, everyone have a good evening and take care. Stay safe.
Thank you. Bye-bye.
Bye-bye.